Please.
All right, so we have a solid line because it's greater than or equal to. And then remember, we have to shade our solution region. So go back to the symbol. It's greater than or equal to. So would we shade above or below? Above. So whatever color you want to use, I'm just going to highlight the inequality so I know that's the color I'm using for that one.
Teacher, please pardon this interruption. Colby Elliott, please report to the front office. Colby Elliott to the front office.
If you struggle to know which side to shade, another thing that helps me is look at your y-intercept. We're on 6 or 0, 6. If it's saying y is greater than or equal to, think about, okay, what numbers are greater than 6? Well, look, above 6 is 7, 8, 9, 10. So you can and that can kind of help you know, oh, I need to shade that side because that's where the numbers are greater than 6 on the y-axis. So that's just another method to help you. Look at the y-axis, shade the side where those numbers are greater than. Question? Okay, so right now we're just looking at this one inequality. Let's test a point just to get a little more practice with the algebraic testing. So what would be one ordered pair that's a solution to this inequality? Troy?
Where are you on the graph?
Yeah, on this graph. So like where is the solution region on this graph? In the shaded area. So what? Give me one ordered pair in this shaded area.
2, 6.
Okay, so 2, 6. Okay, and then remember, all we do is substitute this back into the original inequality. We're only looking at this one inequality right now. So 2 is our x value, so I'm going to put 3 parentheses 2. And then up here we have plus y, and our point for y is 6, so I'm going to put plus 6, and then greater than or equal to 6. So we're substituting it into the original inequality for x and y. Then we just want to solve and see if it is a true statement, just to make sure we shaded the correct region. So what is 3 times 2? And then what is 6 plus 6? Is 12 greater than or equal to 6? Yes. So as long as it's a true statement, whatever ordered pair you chose, that means you shaded the correct side. Now, let's say we picked that point and it was not a true statement, then it just means shade the opposite side. So if you get a false statement, it means you just need to shade the other side of the line. So that means we were correct, and that means we would shade above if you want to add that note. So shade above was the correct one. If you're false, shade below, or whatever the opposite side is. Because yours is different on there. Okay. Then for the other equation, so now let's graph this one. So if it's x plus 3y, what would we do first to get y by itself? Subtract. So remember, always move that x. If the x is on the same side as y, do the opposite. X is positive right now, so we want to do minus x. All right, then we bring down 3y less than, and then I put negative x plus 3. Right, and then remember, if it's negative x, that's negative 1x, and then we would divide by the 3. We're dividing by positive 3, so we don't change the symbol, but just a reminder, if you divide by a negative, you have to flip your inequality symbol. But in this case, we don't need to do that. And then keep our slope in fraction form. What is negative 1 divided by 3 in simplest fraction form? Negative 1/3 x. What's 3 divided by 3? So plus 1. All right, what is our y-intercept? All right, so put a point at 0, 1. What is our rise over run? Negative 1/3. So from our y-intercept at 0, 1, you would go down 1, right 3. If you're going the opposite direction, you would go up 1, left 3. dashed or solid line?
Broken.
Dash, which on our paper is broken, so that's the more mathematical appropriate term. Broken is the same as dashed, and then yeah, what side would we shade? Below. So remember, if it's less than, if we're at 1 on the y-intercept, we want to shade the numbers that are less than 1, so that would be below. So use your other color. Make sure you're going below the entire line. So notice how we are going to overlap with our shaded regions.
This is probably one of the easiest points, because you could just use 0, 0.
Yeah, so that's what I was going to say. If you always use 0, 0 because it's easier. So one of the easiest points that Troy was just bringing up to test would be, see how 0, 0 is in our shaded region? That's the easiest number because multiplying by 0 is just going to give you 0. So let's test 0, 0. So now we're just looking at this inequality. X plus 3y is less than 3, and we're just going to plug in 0 for x and y. So 0 plus 3 times 0 is less than 3. And then when we solve this, we get 0 plus 0, which is 0. Is 0 less than 3?
Yes.
Yes. So that means we are correct to shade below.
What is the test solution?
So now for this side, let me wait till everyone's done writing, and then I'll explain what the test solutions. So here we are just testing 1 point for each of the inequalities.
Oh.
So now this is a system. So where do you think the solution is to both inequalities?
Where it overlaps.
Where it overlaps. So this region right here is our solution region. If you want to write that small next to it. So this is the solution. So that's the only difference with systems of inequalities. It's now like where they overlap. So whatever wording you like some people say the double shaded region, the overlapping, or the darker area, you know, because if it's overlapping, it's going to be darker. So wherever that, they're both shaded on that side. So now we want to test two solutions in this overlapping shaded region. So what's one solution in that region? All right, 6, negative 2. Now, on this, we have to test it in both inequalities. So write small so we can do both inequalities under that. So the first inequality was 3 times x. So we're going to do 3 times 6, because 6 is our x term, plus y. So then negative 2 is our y value, is greater than or equal to 6. And then we would solve it. What is 3 times 6? And then what's 18 plus negative 2? Is 16 greater than or equal to 6? Yes. So it's true for that inequality, but then we also have to test it for the other one, which was x plus 3y. So 6 plus 3 times negative 2 is less than 3. And what is 3 times negative 2? And what is 6 minus 6? Is 0 less than 3? Yes. So that means we were correct with that solution. Oh, hooray. Let's test one that, so going back to what we learned with just when we're dealing with one inequality, what if it's on one of the lines? Like which line would it be a solution? Which type of line? The solid. Now it has to be the solid line that's also bordering this overlapping shaded region. So let's just test a point on the solid line just to make sure it does work. So what would be a point that's exactly on this line? All right, so yeah, this one was at 3, -3. So let's test that just to make sure that still would be a solution. All right, so 3 times 3 plus -3 is greater than or equal to 6.
I was thinking 8, 5.
8, 5 would just be in this shaded region, though.
No, like.
Do you mean 8, -5?
Negative 8, 5.
-8, 5 would be right here. That's not even in shaded.
Oh, wow.
Remember, it has to be in this.
Oh, I had them flipped.
Yeah, so remember, x is first going left or right, then y is going upward. Okay, what's 3 times 3? What's 9 plus -3? Is 6 greater than or equal to 6? Yes. So remember, if it's solid, it has that or equal, so 6 is equal to 6, so that is a true statement. And then the other equation, we would plug in 3 for x plus 3 times -3 is less than 3. And then 3 times -3 -9. And then what's 3 minus 9? Is -6 less than 3? Yes. So it can be on the solid line still, but just remember, like, what if it was on the solid line, like right here at 0, 6? Is that a solution? No. Why not? Right, it's not in the overlapping. So remember, it can only be on this part of the solid line that's touching or bordering that overlapping shaded region. Okay, so in your notebooks, let's glue this other one first. I skipped a page, so I think I'm going to go back and use the page. Or did I skip a page? I think I skipped a page. So I'm going to go back to the page I skipped and glued in on 35, I think it was. Remember, you guys don't have to have the same page numbers as me. So just make sure you're adding your page numbers to your tape. So if you don't want to go back, you don't have to. I'm just going to go back to 35. And notebooks are due tomorrow for a grade, so if you need to borrow my notebook today, feel free to. Okay, so I'm on page 35 since I skipped that. But you do whatever page you are on next if you don't want to go back.
Can we do it?
Yep, you can do it on, if you want to do the same as me, feel free. Okay, I put some extras just in case. So in behind the pencil dispenser up here, there's some glue sticks in there if you want to take another one. Okay. Yeah, because I'm just letting you keep it and you can just use it for the rest of the semester. I am giving it to you. You can take it. Keep it for yourself. Yeah, make sure it's a good one. Some of those are old, so I don't know how many are actually good. Okay, today is the 19th. This one, we were classifying systems of equations. So this one is the equations one. We don't have the shaded region. We just have the line. And this was from this was 2 lessons, 17.4 and 17.5. We combined those two. I'm on page 35. I'll show you my table of contents after we glue both of them in so you can double check that you have everything.
Oh, did you go back?
I did. I went back to the page I skipped. So yeah, your table of contents, if you go back, it'll be a little out of order, but I won't mark you off for that. As long as you have all your page numbers, I'm not bothered if it's out of order. Oh, I just realized I can stop my recording. I was going to forget.